introduce the final chapter of the textbook of NIST. The feature of the step, but as you can expect, the book is a little bit outdated. The book contents is also outdated, but they are saying in the future. So it is interesting to see what happened after this book is published. And what is the real future of the step now. Anyway, the chapter 10 is future of the step, and there is many small sections, and I divide into two, but front part is almost covering the textbook because we need to have a more update, right? So that second part is mostly out of the class textbook. So data sharing, you already see that this is already a bit repetition of the previous chapters, but the author is trying to cover the ongoing development at that time on each chapters. Step development, data sharing, express language, interoperability, change management, long-term archiving, engine analysis, and parametrics, design, and standard parts, electronics, and supply chain. And PDM, PLM, and RP, and product support, the software support is covered here. So the evolution of step, the future at that time still going on is modular architecture. As Soonhung Han is doing on modular architecture for 57 we are developing. So in the textbook they are saying the IGS still at that time is used, but still the IGS is not international standard. IGS is a national standard of the United States, and companies are still implementing single software system rather than standard data. So STEP itself is data standard, not software standard. Or I mentioned one time that Samsung Electronics trying to unify their CAD system with a single CAD system, and that was failed because the company, the CAD software company, was merged into Siemens solution, Unigraphics. Now, so that Samsung Electronics, after that merger, they tried to develop their own CAD system, the Samsung Electronics itself, by merging CAD software company, small company, inside the United States. But that project also failed. Now, the Samsung Electronics is using different CAD systems. So, unification of single software inside the company is not also easy problem. Right? Did I mention that Hyundai Motors also have a different CAD systems? They have two main CAD systems. One is CATIA. CATIA is for body, the structural part of the car, Hyundai car, and also PTC. The PTC is a parametric technology. What is it? PTC's software. What is the new name of PTC? Creo. Creo is used for powertrain system. Powertrain means engine and other transmission something, right? Gearbox and power, including. So we call this as powertrain of the car. And powertrain division, actually, the division of the Hyundai Motors are still using PTC's Creo system. So any car needs to be, the design and development, they need to have a conversion of data inside the company. Also, the Hyundai company also use many small other CAD systems too. So you still need data exchange using standard or direct exchange. So the transition from one product cycle to another product cycle is often accompanied by a loss of valuable information. So data loss is also one of the problem between product cycles, between timeline, even inside one company. Right? Say Samsung smartphone version, say 7 and then 8, also Microsoft Windows version 10 or 11. Between these product cycles, they may use different software system, and then between them there can be information loss between product cycle. And at the time of the publication of this textbook, paper is still a common vehicle method for product information exchange. That is a drawing, paper drawings. Nowadays, instead of paper drawing, they usually exchange PDF file or paper drawing, right? PDF file of drawing. That is more frequent ways of, but still that PDF drawing is sometimes this is just a scanned image, or sometimes it is the character can be recognized. So we need to have a differentiate between PDF. Also, PDF has 3D PDF version too, right? So there are also layers, differences even inside the PDF exchange. But the baseline can be scanned image of paper drawing. Because you can think about the old drawings. 10 years ago, you have an old version of car, old version of nuclear power plant. 10 years ago, 20 years ago, there are only paper drawings available. So that you may have a scanning of the paper drawing to manage the data, handle the data. So that PDF file or scanned image of paper drawing can be inside the PDM system. Now, at the time of 20 years ago, 1995, the real usage of data exchange standard inside United States was categorized in this table, and then you see that this vertical row shows industry, aerospace, automotive, building and construction, plant, oil and gas. You can see that this is a mixture of oil and gas and chemical process plant, and shipbuilding, electrical and electronic company, industry and consumer goods. And then you see that in vertical slots there is a IGS and SET. SET and VDA is very similar to IGS, but this is United States, this is French, this is Germany. Right? National standard, very similar to each other as DXF. Right? DXF is the first initial standard for drawing, CAD drawing exchange. And EDIF is for electronics circuit drawings. And post-procedure was for plant industry, chemical process industry. So you can see that there are marks on and DXF was good in building and construction industry at the time, right? And POSCO is good for oil and gas industry, as you expect. And EDIF is for electrical and electronic industry. And then you see that IGS is for good, better for aerospace and automotive industry inside the United States. Probably VDA-FS is from Germany, and they are strong in automotive industry. they are trying to move into a step world from IGS. Right? So in step, and possible application of step is divided into timeline of product development, design, analysis of the product, and product data management, PDM, or nowadays we can see PLM as instead of PDM. So this is the old name of PLM, and manufacturing itself, or machining. Right? So it's a timeline. And then if you think about more processes in design, you can see that this is for automotive industry. Chassis and body in white is probably for the body of the car, not the powertrain part or electronics part. Analysis may be finite element method or CFD and other things. Right? And PDM is database management system for engineering information, so that you need to archiving long-term retention of data or legacy data, old data, and bill of material, or we call it BOM. And also you can think about configuration management or long-term data handling of design changes. Say, for 50 years of nuclear power plant, you see that there are big changes. Right? Say you can think about your house, your home, for a long time of 10 years period, there are things are changing inside your home. Right? Many, especially the electric devices are changing. Right? And configuration also changes. So that you need to manage the information changes of that product or that plant, especially for safety devices of facility such as nuclear power plant, aerospace, airplane. Right? It is very important to keep track of the most changes. And finally, the machining or manufacturing, you need to have talk about numerical control, measuring, coordinate measuring system, and rapid prototyping. And those areas you can apply step standard for exchange of engineering information or design data. And modular architecture, modular information, modular approach is already covered by previous lectures, so it is just a reminder for you. So application protocol, application interpreted, constructed, they are the previous concept of modular architecture, or modules, application modules. Right? So baseline behind the idea is component-based development, CBD. This software development methodology, component-based development. Right? So components of software. This is very similar to component of hardware. Right? Component of hardware. If you think about a car, you usually think, talking about 20,000 parts. 20,000 parts of a car. Right? So how many parts? And that number of components, 20,000 components of a car is assembled into one car. Right? Similarly, you can develop a software, standard component of software. And you can exchange, or you can buy and plug and play software component to make us simply developing your software. So that is the idea of plug and play environment and CBD behind that modular architecture too. And why we are doing such a one? Because we want to have an interoperability among APs. Right? Very similar to car, hardware. you can use same bolt and nut to another car, right? Or you can use same, say, motor, electric motor to another car, or you can use same, what is it, windshield browser, or that can be interoperable or exchangeable, or you can use engine itself too. Right? Same engine to another car can be used for. So, and then the cases are in step world, the AP development, they want to use same modules, same software component, once again, many times. And standard set of components, standard set of modules. And shipbuilding industry was the first runner at that time in old days, more than 10 years ago. So that the ideas coming from in old days of APs and CDIM, we already covered this one in previous slide, and then it becomes into a AIC concept, so construct. But this is just a software kind of classes of schemas. Schema set, small set of schema. They can be shared by different APs. So this AIC is shared by this AP and this AP and this AP. But now it's growing into module architecture. So modules can be used once again and collected and plug and play. So it's a little bit development coming from AIC concept. So in previous ideas, the AIC was a set of divided part of AIM, but nowadays the modules is a little bit expanded, including not only small AIM, but also ARM together. Right? That is difference. AIC is just a division of AIM, small set of AIM, but module is more, say, object-oriented concept. It's a completed functional component. Right? So that they need to include ARM and AIM together and a small mapping table. So collecting those modules and then umbrella type of the highest level list of modules and also activity model and conformance classes, we can arrive at quickly, hopefully to quickly develop AP. And this one is also some person draw this idea again in different viewpoint, so that they want to develop a module repository, right? So we are doing some step module repository, what is this? SMRL library, right? SMRL, step module repository library. That is module based on modules and existing ISO international standard, and then validation of module and repository inside that, and then the APs can be quickly developed. So the other is validation is done by step centers. Step centers is a national step centers. So Korean step centers is one of them. And StepNet is a network of step community, international review for validation, test rally, and PDM also test rallies too. And then they arrive at international standard quickly to that. Data sharing, SDAI was the key word at the time. But SDI is for something like the API, right? Application Protocol Interface, so that programming interface, application programming interface to data access, so that Oracle database they usually also provide APIs for programmers, database programming. Right? So very similar to Oracle API. And that is handling the express schemas. So SDI allows the integration of software. That's software components. That is software components. Similar to this one. Software components or modules. Modules coming from different software vendors. So they are trying to separate out implementation from design. So data dictionary or repository of using express language. And the express language itself, it is a language for information modeling or information description. The properties of data set. And there is a shortcomings too. Disadvantage of missing point of express language comparing to the UML language or XML language or Python language. Right? So they were trying to improve express language too. So there is a second edition of express already there as a programming language. They express what is a shortcoming constraint description, but they want to make a more logic-oriented ontology, our language, something like that, or reasoning, more intelligent language. And about compatibility, this is say Windows 7 and Windows 8, Windows 9 as versions going on. Sometimes the old version files cannot be opened. Right? Microsoft Word 2. Right? That we are saying upward compatibility should be provided so that old version file can be used by new version of the software. We call this is upward compatibility. So product data or product drawings is an essential corporate asset. Say one company, Hyundai Motors or Samsung Electronics, the design data itself. This is very important for them, right? Most important property of each company, right? But if the definition of the standard is constantly changing, right? Not constantly changing, but regularly changing, right? Updated. So step itself can be also updated, right? Updated, even though it is standard. So this must be, the new version should have upward compatibility too. Right? So step itself should be improved because this is also software and data and IT technology. Because there are so many new technologies coming, emerging technologies too, right? Smartphone, big data, IoT is coming. So that step need to adapt new emerging technologies. And also industry requirement is changing. So that step is moving, but also you need to have a standard about the compatibility. Interoperability, I already told you before that between APs is a major emerging issues at that time. So that aircraft industry in the United States, Boeing say, wish to operate AP203 data or drawings. They design is used for AP203 with AP209. 209 is for finite element method standard. Right? So how can you working together between APs? Right? Also, they do same thing in very different ways because different organization, because of different context and domain expertise is different. And ontology is one of the solutions. So ontology is trying to have an intelligence like a proving forms or reasoning, and also vocabulary of terms, the taxonomy of terminology, something like a dictionary. In dictionary, you saw that word is categorized into alphabetical order. Right? We saw this is a taxonomy something, and classification of terminology, right? Vocabulary. So that SH4 community has not agreed on the manufacturing process names. Name means vocabulary. So there are different names and vocabularies are used. We need to have a standard terminology too. Standard of terminology. That is the first thing you should. So it looks like a trivial thing because it's only a terminology things. But mismatch of meaning and vocabulary and terminology, that is a problem for interoperability. So that there is a syntactic mismatch, also there is a semantic mismatch. Same meaning, different wording, different terminology, so that they can provide. So in old days, you can remember that Google search was, probably you cannot remember this, only syntactic search. If you type in misspelling, they could not provide the answer. But nowadays, Google search engine is clever now, right? So that he replies that, do you mean this word? Right? Do you mean this word? So that they have a reasoning capability now. We call this a semantic search. Semantic search. They are trying to use meaning rather than alphabet. Right? Change management. Change management is management of changes, but now they are talking about change of step standard, management of standard document itself, so that there is a special wording called the SCDS. Standard is changing, improving, because of technology is improving, but there is differences, discrepancies. So we need to have measuring how different it is. Right? So changes is okay. We should allow changes, improvement, enhancement, but it should be have a upward compatibility. Similar to Windows 10, Windows 11, Windows 12. All proposed modification or enhancement should include an impact statement. How will be the impact of changes? If you allow to use new nuclear emission or engine something, right? Then what can be the impact to the environment? So you should have a report on this. Migration paths, how can you smoothly change into new version of the software? Right? That is migration. Because every 2 years there is changes. How can you survive in existing implementations? Can you upgrade all the software and hardware at one time? And archival requirement of so long-term archive. So we need to have a time-stable representation of drawings, or data, digital data. Then that of proprietary applications native file format, right? Very similar. CATIA software, they have a version 10, version 9, but now we are using CATIA 15 or Microsoft Word version is upgraded, but their old data, you cannot, sometimes you cannot read this. Very similar to, say, 30 years ago, the nuclear power plant was developed or designed. Right? But what system are at the time used for? AutoCAD, probably. But can you open that file 30 years ago? There is a problem. So old versions of software and hardware and data set, but the main property of the company is the drawing itself, the design drawing. Right? So data is most important than software for a company. Right? Design of Sonata car 10 years ago, 20 years ago, that is important. So how can you access this? So you need to access the old data, 10 years ago, 20 years ago. So long-term data archiving. We already see this slide before, right? So design data should be approved by, this is for airplane industry, because this is PDS of United States, FAA, but also 50 years or more. So you need to have a product itself, the drawing, but storage inside USB or hard drive or internet, and software itself is also very short life cycle, right? Shortest is 3 years average. Storage is already be say 10 years, but you see that all the operating system and application software, they changing, upgrading every time. But after 50 years, what happens? Some long-term data retention is important for 50 years of airplane, 50 years of nuclear power plant, and hardware and software systems are changing. But see, the older design of any product is 80% is just redesigning, right? Upgrading of old designs. So old data is important. And engineering analysis, there has been a ESPRI is a EU, European international, inside the EU, the big project at the time, and also EACM project inside the United States, and they produce this kind of AP209. This is for engineering analysis core model, trying to standardize finite element method representation models. And design intent and parametrics. This is, we are working on 57 standard part of Sunja and myself is developing. This is the exchange of parametric models. Also, your term project is related with this one, right? So, because 80% of all new design is adapting or improving existing designs, they want to make changes easily, right? So, parametric changes is important. NGen was a project inside the United States, and CHEPS also related with this one. And macroparameters is from our KAIST ideas, right? And this is just one simple idea for parametric chassis design models, so that they easily modify and car designs. Also, they are talking about modular technology too, right? Modules. So modular concept is used in many industry. Probably most of the industries are using a modular concept nowadays, including electronics too and plant industry too. Standard parts, it is also related with this component and parts, right? Rear part, the electrical motors, and also bolt and nuts and pipe pieces and valves, pumps, right? So existing design of this regularly use many parts or module as managed by a database technology. So Henry Ford, 100 years ago, with using interchangeable parts of mechanical component of car, so they can make a mass production, because the parts are coming from different small companies. Same bolt is designed by Ford but manufactured by other companies. Nowadays, same car, Volkswagen Golf, is produced by inside China, inside Germany, inside Brazil too, right? Same car is produced, so that they are interchangeable part is manufactured and used by different portion of the company. Engine, motherboard. So we call this is something like a library or catalog or database or other or repository, standard part or standard modules or standard components. Electronics, EPs, it is embedded software, embedded electronic system inside the car. Smart card is embedded software, or chip, smart chip, or smart military system. So there is a EDA, electronics design circuit board, and F3I, and also IEEE is VHDL, and finally the STEP AP210 is coming for electronics industry. And I told you that LK Software of Germany was leading in this world of standard. And supply chain management, I told you about the outsourcing and Ruji factory of Ford. And then there is a ERP development coming from MRP. Right? And supply chain was very important at that time, 10 years ago, because of the outsourcing. And EMS was popular names for outsourcing. And they trying to do lean and agile manufacturing. Do you know what is lean and agile? The meaning of agile? Did you learn from your Professor Teshik? He is also very interested in this topic, right?
Maybe.
Maybe?
No, lean manufacturing is about the concept to reduce waste. Reduce wasted time, improve the efficiency of the process. It's like a philosophy more than a technique. And agile manufacturing, maybe it's related to flexible manufacturing system, but I'm not sure.
Right. Lean means the company itself can be smaller by using more outsourcing. So the factory itself, the Ford Rouge factory, at one time it was a very big site and very big number of employment at one site, right? Now they reduced into only small assembly line, right? And number of employees is very small, right? Still they producing more cars. So the size of the company itself is reduced to lean manufacturing. Why? Because another reason is because of agility. Agility means flexible, yes, flexible, but flexible to changes. Say, because I ordered this color of clothes, million sheets of this color of clothes, but because of the weather change or because of fashion changes, they don't want to buy anymore this kind of shirts, right? Then what? I should change my design. I should change to another design, right? Design, color or size or shape, right? So it should be flexible to change our market, because market is changing rapidly than 100 years ago, right? So that outsourcing is good for this. Outsourcing is good, right? That is another reason for outsourcing. They change, if you want to change a Ford car model inside the Rouge factory, you should change big amount of employment, big amount of storage of material. Eh? But if you have only assembly line, and then the others are all outsourced, then you can change easily, right? Because you are handy size, right? Your body is very small. So because outside world and market is changing rapidly, right? Say 10 years ago, the new car development cycle was 50 months to change to a new generation of car. Nowadays they are saying 12 months to provide new car, because competition is heavy Now you can think about the smartphone, the new cycle of new design and new development of new version of smartphone. They are saying 6 months to the market for the new design of smartphone. So its timeline is reducing. So then you need to have a more agile response to the market changes. Right? Pilot evaluation, you already see that. Step automotive. You see that this slide many times. And product data management, PDM, now it changed to PLM. Right? PLM. So AP239 with PLCS. They are trying to handling unit of functionality, something like part identification, authorization, shape, assembly, effectivity, work management, end item identification, document reference, management resources, security classification, contract, and certification. And they are related with these APs. This is also very related explanation of PLCS. PLCS is baseline for product lifecycle support of AP29. But looks like this is very short, it's very small. This can be 50 years. Even though it can be 5 years or up to 10 years for nuclear plant. Probably 5 years. So you need to have this one is very 10 times longer. 10 times longer. Anyway, you see that design, demonstration, manufacturing, and in service, operation and maintenance, and disposal. This is whole life cycle management. Operational feedback. Okay, rapid prototyping is for similar to 3D printing nowadays. Right? They want to make us quickly make a prototype parts directly coming from CAD in one day. In one day. Right? Otherwise, it can take 1 month to make one small pump, one small tank, or one small motor. Right? But they want to make 3D printing by 1 day to make idea quickly to test them. So in old days they use layer by layer printing of usually plastics, but nowadays they want to make a metal powder printing of them. Product support, softwares, we already see last time. Software tools for step translation. So compatible libraries and database. And I explained this one last week about Step Tools Software Company, EDM of Norway, Eurostep of Sweden, and LKsoft of Germany, and ProStep of Germany. And translation centers. In 10 years ago, General Motors opened the Step Translation Center in Troy of Michigan. 20 years ago, okay. Not 10 years ago. And then Delphi is also a subsidiary of GM, and GM Powertrain is another division. Powertrain means engine and transmission and gear, right? And Delco is for electronics. They also use it. Okay, question? No question? And then we can have a 5-minute break. Okay? We can continue on the second part. It is rather short, but we already no time. Anyway, see that. So this is already done. It's the last part, but this is more slide there. So 16 is also long, right? So COBA is coming, EDI and OLE, Java, Mandate, and SGML. So you see that this is already outdated names, but there are more outbreak of these old names, right? So the concept is still there. And the sibling, the neighborhood of SH4 is Step NC is SH1. SH5 is nowadays very active because of the smart manufacturing and Industry 4.0. And they are doing the device level interchange of standards. This is one slide for showing Step NC. The machining itself, nuclear control machines, machining center. So the CAD and CAM in old days. And then COBA was old name coming from OMG consortium. They want to integrate software components. So it's of course very similar to CBD related to this idea. They want to integrate components coming from different vendors. So they have a idea called IDL language. IDL language is something like we call say wrapping of the software component to make a very interchangeable component. So make us same coatings around the different software components. Now the idea comes growing into web services. Web services also a little bit outdated nowadays. Nowadays, app is very new word, right? App of smartphone. There is very similar idea behind web services. App of smartphone. And internet, e-catalog, electronic catalog is dictionaries. And before the internet explosion, that was internet explosion is coming from World Wide Web, but Step Word is starting before the World Wide Web. So they moving into this new technology. So Java is also, XML was also too. And EDI is for electronic business world, not electronic exchange of business data. So they want to unify. This is coming from UN artifact. EDI, electronic data exchange of business data. And you can think about Alibaba. Alibaba is for trading, right? E-business. So it is an old name of EDI. EDI is becoming into internet shopping.
Can you go back 2 slides to the Step NC?
Step NC.
Yeah. What is this exactly?
What this really means?
This is a software developed by...
Step NC, yes. You know about G code of NC? Right. They want to replace G code. So this is very big work, including you should change the control of the NC machine too. But the goal of them is they want to send step drawing, step file, AP203 to machining center. They want to convert the step design model into NC code, not G code, step NC code. And you need to have a new controller to handling step NC command instead of G code. Right. G code is developed in 1960, long time ago. So they want to.
But it's still being used now.
Yes, still. They want to replace G code into step NC. Still working. Yes. COBA, once again, is moving into web services. The same idea again. Internet and intranet catalog. Oh, okay, I already explained this. OLE was also related with COBA. OLE is coming from commercial world. It's coming from Microsoft. So you can think about COBA version of Microsoft or web service version of Microsoft. And design and modeling, right? And Java is also not so new, but they was also new during the step development. So they have a Java binding for step SDI APIs in one time. And mandate is for manufacturing management. Now it is unfocused because of the smart manufacturing and Industry 4.0. They are trying to handling manufacturing resources. SGML, once again, I already told you many times. And VRML is also outgrowth into the X3D nowadays. The Web3D consortium developed in 10 years ago. It was VRML. Now changed to X3D. Finally, we have to arrive at the conclusion. What is the future of STEP? They need to have a CQT. CQT is cost and quality and time. This is most important things for any manufacturing industry. Among them, I can say the time is more important nowadays. And this is good for ICT technology can help. And in enterprise integration, data archiving, and these things. And why we need to have a standard? Already saying many things, and especially the outsourcing was important. And already see this in the beginning of our classes. Tower Babel, we need to have a standard. And BOM, there is a different versions of BOM. And one is planning BOM, engineering BOM, and manufacturing BOM inside one company. So they want to make a unified BOM, single BOM. But this is not easy. But anyway, each stage of engineering process, you need to have a parts list. Because in design changes, if you making change in later stage, then the cost is very high. So you need to have more review or testing or concept in early stage. That is important. Virtual factory, of information interchange, of outsourcing of OEMs and component suppliers and data. And EMS once again, we already explained this one many times, is a very keyword for outsourcing too. Okay, that's it for today. Then, question.
All of these tech projects and new standards and new APIs being made, how can one participate or know what's going on? Like, how can we get updated information and help with this project?
Oh, yeah.
If someone is interested.
Right. In old days, there has been so you can Googling first. There are so many information around on the web. And then second stage, you need to attend the meeting. So to see the people who is making and who has a knowledge of history and technology too. That is the second step. Third step can be you participate in a project like our doing. That can be the third step. There are more.
Project funded by who?
Usually big companies, government, military, or yourself. But it costs much because standard is very expensive to develop. It takes a long time. It is international traveling. Right? So time and mostly cost is time, the salary, and then traveling.
You have to be a member of some organization to...
No, anybody can come. But officially you need to be, I'd say, you are from Egypt, right? Egypt is not so member of SH4 meeting. But I'm sure that it is a member of ISO, but not to the SH4 community. But anyone can attend, but there is also registration fee because of the eating and the office, the rooms are shared by. But if you pay the registration and pay your travel fee, you can participate. It's open. Very similar to conference, right? Okay, then we can move on to this.
I'm very sorry that we have short time.
You have many discussion items.
First, in the future, I don't know if that will become what. So I guess step will become more general or more strict step. So I made two teams, and one is general team and one is strict team. And first, the general means the capability that can contain lots of companies' standard, companies' needs or something. And one is, and the strict means that its own powerful standard. It means it makes its own outstanding standard. So it makes other company use this standard. So who want to choose the general one?
Can you give an example first?
Example? There is no example. It is future step.
Do you have many topics for debate?
What?
Is this the only topic for debate?
No. There's.
Can we choose one topic then?
Okay.
There's only
This is about long-term data, the reuse of VS versus the redesign. Reuse means we are using old product data by its old format or changing it to new format, and it's wrong. The redesign means remaking the product data for adapting the new software. For example, the reuse. We have the old drawing, and so we extract the design data to the new 3D format, and the redesign means, for example, we scanning the product and then we are doing the reverse engineering like that. This is an example. What topic want to choose? This one? Ungsig and Mohammed, the team we used, and Hye and Wang Ning, team redesign.
So obviously it's more time efficient to just read the same old data without having to remake it. So reusing it would be better for the company because they don't need to put the effort, put the time to redesign everything, and they can just modify it. So what's the audience of that, guys?
But the old data is hard to find. First, hard to find, and then it's hard to translate new format.
Yeah, or assume you already have the old video, right? And you have to have it from before. So we should not be trying to find video. What was the second point? Sorry, you mentioned something.
Second point?
It's not easy to update. Give it the right software, maybe is a big goal. Or if you keep an old version of the old software, you can always create updated in the old software. So I think it's possible. So it's not impossible.
Whenever redesign product, it spends too much time. We develop only changing format software, so it reduces time to redesign.
It is easy to say that we're using more data all the time. It seems convenient and seems profitable for company not to redesign everything, but it's case dependent. I think every case will be slightly at least different, and not all cases you can use the old data. Whether it will be more easier or better to redesign from scratch for the new purpose.
Like for redesign, it doesn't mean like we have to totally design everything that is new. Just like we have the current design, and we can make some modifications depends on changes based on the current data. So like therefore, because the technology and even the world is like they're developing so fast. So like the long-term data cannot ensure that everything can be like guaranteed based on the current design. So sometimes we have to make new design and to even to make the product to be quite adjustable and even quite attracting to even the customers and even to engineers. So like for some cases, for example for the car design. So if we always use the same the same data, and nowadays like even auto driving and even some kind of more developed technologies have been used in the car. So if we always use a long-term data, so there will not be any kind of like technology innovations. So we always like stand in the point, like in the original point, so we cannot make any developments. And sometimes like we design and we find something new and we are trying to put it into practice, and so like this kind of process even can be more like I think it can be more beneficial even to engineers and also customers.
I think our time is up.
The previous one, you can replace the second. Yeah, replace is better to replace like this one, like the superset or minimum set, common set, superset or minimum common set, minimum common set. This one is something like this one, right? This one. And the superset can be this kind of superset. And minimum 성격이 something like this. You are talking about this similar thing, right?
Yes.
So it's better to understand.
When I say too